Right, so this is quiz 2, and let us look at this picture here. So what we have here is we're trying to calculate the value of the closing work in progress. I suppose the question is, what is that work in progress? So you put in 9,000 kilograms. You put in 9,000 kilograms, and you're told that 8,600 of those kilograms are finished. Right, you're finished working on 8,600. So that means you have 400 kilograms that are work in progress. So what you have here is you have 8,600 kilograms that are 100% finished in terms of material and that are 100% finished in terms of labor. So you have 8,600 kilograms here in terms of material, and you have 8,600 kilograms here, if you think about it like that, finished. But in terms of your work in progress, what you have is you have a situation where you have you're 85% finished in terms of material. So if you're 85% finished in terms of your material, that means that is the equivalent, if you like, of 85% times 400 kilograms. If you're trying to get full complete kilograms or full complete units, you see, because you can't add you can't add 600 kilograms full units to 400 partially finished units. You think of 8,600 tables and finished tables and 400 partially finished tables. You can't add them together to know what the value of the inventory is. So we need to find the equivalent units. But these are also only 70% complete in terms of labor. So just changing my pen color, therefore, what this means is that this is, if you like, the equivalent of this is 280 kilograms complete in terms of labor, and this is, let's just do this, 0.85 times 400, and this is 340 kilograms complete in terms of material. So in total, in terms of completion, what we have, if you like, in terms of material is 8,600 plus 340 in terms of material. So that's 0 8,940 complete materials in terms of material completion, and in terms of labor, you have 8,600 plus 280, and therefore you have 8,800 kilograms in terms of labor. And we know we've spent, just changing my pen color back to black, we've spent 18,774 on materials, and we've spent 4,884 pounds on labor. So the equivalent cost of a kilogram of material, of course, must be 18,774 divided by 8,940. And for labor, it must be 4,884 divided by 8,880. Right? So let's just do this one. 18,774 divided by 8,940 takes us to £2.10. So this is the cost of each kilogram of material. And when you do the 4,884 divided by 8,880, you have 0.55 per unit of labor. So therefore, it means that 400 kilograms, or partially finished kilograms, because that's what we have here, 400 units of work in progress, which are partially finished, 85% finished in material, 70% finished in terms of labor. But we know what the equivalent units are. It's 340 kilograms of material. So this is at £2.10. Plus, of course, you have 280 kilograms in terms of labor at £0.55. Right? So when we do this, we have 340 times £2.10, which is 714, plus 280 times 0.55, which is 154. Add the two together, and you have 868, right? And that's how we arrive there. So the point here is you want to look at this, identify the work in progress, which was 400, which was the difference, of course, right? and then you now need to, because you can't quite measure 400 partially finished products, you need to sort of say, well, let's break that up into what they are. It's labor and material. So you have 85% material and 70% ready. And so what's the equivalent units? Work out the equivalent units, and you can only add equivalent units to be able to find out what the cost is per unit, right? And that's what or per kilogram, and that's what we've just done there by creating the equivalent units, and therefore we can come to a sort of cost per kilogram, and then we can apply that to whole kilograms, right? Cool, great stuff. That's that question. That's the first question. Right, this is the second question, and this is to do with, it's a process, and what we're trying to do is that we have, sometimes you get questions where you're actually given the actual joint costs, and you actually have to split them up. So it could have been 50,000. So if you remember, you could have a process, and you have kind of like similar to this, you could have two products, M and N, and then there's the costs of everything that have gone in here. Maybe that could have been 100,000. But then when you get here, you could split this cost based on weight, if you remember. But this time they want you to split it based on the value of these products at this point before it goes into further processing. And it's telling you that the selling price, if you like, per unit, they're asking you to use the sales value at the split-off point. Really, I suppose this question was probably best really highlighting selling price. To be fair, that's all you have, selling price at that split-off point. And these are the units that have been produced. So here at M, you have 5,000 units, but each of them are at £30. So that's their value. Here you have here 15,000 units, and each of them are £10. So here you have £150,000, and here you have £150,000. So in terms of value, you have 150 here, and you have 150 here. So in effect, you have literally the same value. They're valued at the same thing, which means that we will split this cost equally between M and N. So that's a 50% split for M, and it's 50% split for N based on that split off point. Cool, great stuff, and that's this question. All right, and what we have here is when you have a scenario where costs can be directly associated. So this is still to do with absorption in the long run, but we're just trying to first of all map a cost to a cost center. And when we can charge it directly, when we can almost accurately ascertain, so like machinery cleaning costs directly to the machinery department, and no other department, then we, if you like, can allocate, right? And when we have to share that cost, right, because we're not quite sure, like rental space, because you have two departments in the same area, we are apportioning. So the answer here is, if you like, allocation and apportioning. That's really the principle. So direct mapping, allocation, and when we have to share, apportioning. Right, and this question really is telling us, listen, when you now have all those costs in a sort of production department, and where we have units, how do we spread those costs over the units? Well, we absorb those costs over the units. Which is why this is neatly overhead absorption, right? Overhead absorption, absorbing those costs over the units. Okay, let's look at this. This is trying to get the overhead absorption rate. So we have three products, X, Y, and Z. It said it budgets to produce 10 units of X, 20 units of Y, and 30 units of Z. And then it tells us that in terms of machine hours, it takes 5 units to make each unit of X, 10 hours to make each unit of Y, and 5 machine hours to make each unit of Z. So we have a total number of machine hours as follows, right? As follows. Therefore, you have all these hours driving, if you like, a total cost of £10,000. That's the argument here. So the total, of course, is the 50 plus the 200 plus the 150, which is equal to 400 machine hours. 400 machine hours. So 400 machine hours are causing £10,000 of overhead, and therefore 1 machine hour. So that's what we're really trying to find here. How much does a machine hour cause? So that's what we mean by the overhead absorption rate. So in effect, we have 10,000 divided by 400. And so we now have, if you like, 4 into 100 is £25. So we have £25 per machine hour. That's what absorption is all about. Trying to map or absorb an overhead cost over all the hours involved, so we can then attach and treat that, if you like, when we're building a sort of a product. If we say, oh, well, what is the cost of a product? All we need is direct materials, direct labor, but you also need a certain number of machine hours, and we now know that we will assign £25 to every machine hour. There you are. So great stuff. So that's £25 an hour. Right, so it says a company has decided to use repeated distribution to reapportion service departments. And if you remember, what this meant was that, remember, we had repeated distribution, we had we had the algebraic method, and then we had the final method where we would deal with one department and then shut it down. So specified order of closure. And all those three methods had scenarios where the service departments carried out work for each other. That was why we were using these ideas. So repeated distribution literally keeps on reducing the costs, well, sharing it and then resharing it and then sharing it and then resharing it between the service departments until it eliminates all of them. So really the answer here, none of these, it's not about whether or not the service departments are more than the production departments or anything along those lines. It's simply about the fact that we have the service departments working for each other, and hence the answer here is the last one. Okay, great stuff. So I think it's really important to understand what's happening here with overabsorption and underabsorption. Again, hopefully you'd have done some revision to review how this works. These budgeted figures here of 100,000, if you like, are done at the beginning of the year, right? So at the beginning of the year, you have costs of 100,000, and they've been apportioned on the basis of direct labor hours at the rate of £1 an hour. So this is the overhead absorption rate here of £1 an hour. This is the plan, that for every hour that we get, we will put in £1. Every hour that we incur in the factory, we will put in £1. So we must have budgeted that. We think, listen, with a cost of 100,000 and with a budget, we think we will spend 1,000 hours. Oh, sorry, 100,000 hours. 100,000 divided by 100,000 is equal to 1, because this is a budget, right? And so you set this at the beginning of the year to help you with pricing, to help you with just with anything, making decisions. Now, during the year, you now actually do 130 hours. So what you're doing is every time you get an hour, you put £1, which means that when you do 130 hours, you will have this, right? You will have the overhead expense and the accrual, right? So you will put in 1 times 130,000, and you will create an accrual of 130,000 as well. So you'll have an expense of 130,000 and you'll have an accrual of 130,000. So your accounts will be showing 130,000. I mean, that's what you have here, because you're putting in £1 for every hour that you work. Right. Now, what will also happen, we can see here, is that at the end of the year, you now find out that your overheads are 110,000, which means that you've put in too much cost, right? You've put in too much. So you've overabsorbed, right? So you need to reduce this. So you will put through another journal of 20,000 to reduce this. So you have overabsorbed by 20,000. That's what you've done. Overabsorbed by 20,000. Okay. Okay, right. So here, what they're really asking us is, when would activity-based costing be beneficial? Now remember, the difference between traditional absorption costing and the ABC is that the ABC is saying that, listen, you have these overheads that are not really driven by volume. See, the thing about volume is that with volume, we associate labor hours with volume. We say that the more labor hours you have, or the more machine hours you have, the more overheads you have. This is traditional. This is traditional absorption costing. With ABC, you have overheads like quality inspections and um, um, setups, and if you like, procurement. So you can have 10 setups and 10 quality inspections for one little drug. It has nothing to do with volume, but you have very high overheads for this little drug, this little vaccine. Imagine. So ABC is saying that, listen, when you have non-volume related items, it's not about volume, but you have these overheads that are really important. You want to know what's causing them, right? So to kind of work here, if you have a lot of proportion of, if a high proportion of your costs are indirect, like a lot of them are overheads, you want to go with ABC because you're saying, listen, let's go with ABC because a lot of our costs are overheads anyway, and we want to correctly and appropriately share these overheads between the products. That's the first point. When you have products in differences in volume, processes, complexities, and lots of support, so again, very similar to this, these are very overhead centered products, and we want to make sure we get the right apportioning into the product. So ABC is very helpful here. So here again, you have complex products again appear to be very profitable. So we want to get the overheads right. We want to get the overheads right. And the idea of having complex products really drives the need for ABC. ABC. You see here, what we see here is that, first of all, you have these small product ranges, a low proportion of non-volume related overheads, and direct materials and direct labor are the main thing. So where you have direct material and direct labor and very small overheads, well, traditional absorption costing can do the job for you by splitting it according to the products, because most of the costs are dominated by direct materials and direct labor. So in this one, you can sort of argue that, well, we don't really need ABC here, because ABC would be trying to break up these overheads into finer points, but they're low anyway. They're not many. So what am I saying? At the end of all of this drama, what I'm trying to focus on is that we don't need ABC for the first one, right? We don't need ABC for this. ABC is wasted on this first one. It's too much money. It's too expensive to be spending all this time collecting all this data when you have very few overheads. So the whole point of absorption costing in general is, how do we get the overheads fairly into the overheads fairly into the products? And if these are very small in size, we can just go with traditional absorption costing, just break it up based on hours or something. But the more complex they are and the larger they are, we want to be going for ABC. So the answer is A. The answer is A. Right, so what do we have here? We have a company manufactures kitchen equipment using absorption costing, where machine hour rate is used to determine costs. So the company overheads are 180,000 a year, and the budget, well, it says 180,000 a year. The budget is based on 1,500 machine hours a month. So therefore, over a year, because it has to be, right, this is the cost per year, you have 180,000 over 15,000 times 12, which is 18,000. So what you now have in effect is you have £10 per machine hour. Great. So it says the mixing machine takes 2 hours of direct labor, 2 hours at £25 an hour. You also have direct materials of £35, right? And overheads are based on machine hours, and so direct labor is £25, and that it takes 2 hours of direct labor and 2 hours of machine hour, right? So machine hours at £10 an hour, so machine time at 2 hours is 10 times 2. So we have, what do we have now? We have a total of 35 plus 2 times 25 plus 2 times 10, yes? So we have, this is 50, this is 20. So 35 plus 50 is 85. 85 plus 20 is £105. So the total cost of a unit would be £105. Good, and that's that one. Okay, right, so this question wants you to apply the specified order of closure. And the way this works is, again, by what we have is we have two support departments that service each other. And the question here is, which department do we close first? We always close the department that has the larger percentage of its service. So Y, 25% of Y's servicing happens to X, as opposed to 10% of X servicing that happens to Y. So we always close the larger percentage. That's the point. And this is for statistical purposes to reduce error. Yeah, that's sort of the first point. We distribute this the first and put this into, split this first. So we split the one with the larger percentage in its service to the other. That's what we always do first. The other reason, hopefully you can see it here, is that most of X's cost will go to A and B. So it's best to get it all into X, actually, so we can almost split all of X's between A and B, if you like, because that's what's going to happen in a second, right? There's a higher chance we'll get this right, if you like, anyway. So that's the key thinking there. So that's the 300. So let's split that 300 into, and then get rid of it. So 25% of Y will go to X. So 300 times 25%. So 75 will go to X. So X is now 275. And then half of Y will go to A, and that's 150. And then the other 25% will go to B. So this is what will happen right now. And then that's the over. Y is done. So we now have to split this 275 between, because Y is done, and all we're now left with is X having this cost of 275. I mean, because Y is done, we just have to split this 275 between the 40 and the 50%. So we're saying split 275 in the ratio A to B, 40 to 50, right? So in effect, that's just A is 4/9 times 275. It's not a pretty number. 5/9 times 275. Right. So what do we now have? We have 4 divided by 9 times 275, which is 122, 122, and therefore deduct that, and then you have 15153. Right. And so the total cost here in production A is therefore 1,500 plus 150 plus 122, and the total cost here is in B is 3,000 plus 75 plus 153. So you have 1,500 plus 150 plus 122, and that's 1772. And here you have 3,000 plus 75 plus 153, and here you have 3,228. Yes. And that's how these costs would be shared between A and B. A and B. All right, great stuff. And that brings us to the end of quiz 2.